test recording. Couple of things before we get going. First of all, I thought the test went fine. I'm hoping you thought the test went fine. Yes? Any feedback that you have, you can also email me or you can submit it anonymously on Moodle if you want, but any feedback on the test, any, Dr. Meyer, you didn't think about this and it totally stressed me out during the test, anything, you don't have to, but if you want to and have feedback, you guys were my guinea pigs. You were the first of my classes who had a test. So anything, no is fine, but it seemed to work okay. It seemed to work okay. Okay, all right. So along those lines, I did not email this out, but I'll share my screen with you. I did put a revised schedule on Moodle for the rest of the semester. So it's under class resources right here. Here's the revised course schedule for the rest of the semester. So you can take a look. Like I said, 2 weeks are down. We've gotten 2 weeks down, and then today we're starting 8.1. One thing to point out, so this Friday obviously is Good Friday. There's no class then for Easter break. Monday, I am also going to give you off. So normally with the revised schedule, Monday would be an instruction day, but I'm going to give you, you can do whatever you want with this, obviously. But the reason I am justifying giving you a day off on Monday is because that's a day for working on your proof notebook. So you can decide what you are going to choose to do with Monday, but that is my rationale for giving you Monday off. So what we're going to get to for the rest of the semester, chapter 8, a little bit of chapter 9. I'm just grabbing my book here. I just have section 9.1 written down. Yeah, we're just going to do counterexamples. Chapter 9 is kind of like existence proof, so chapter 9 is nice and easy and simple. We're going to do chapter 10, but just the first section, mathematical induction, and we're going to spend a couple of days on that. We are skipping chapter 11. Normally I would cover chapter 11 in this class, but with losing that second week to an extended spring break, that's what I chose to skip. So we're skipping chapter 11, and then we're gonna skip around a little bit in chapters 12 and 13. So that'll kind of be with the end of the semester. This is also tentative, but this is at least you have something now to do some planning. And these are the tentative due dates for the homework for the rest of the semester. So I kind of wanted to give you a little bit of organization so you can plan your life a little bit and see when stuff is going to be. And then remember, the third test is just a test. It's not a final exam. Your proof notebook is kind of your culminating project experience, but the last test is going to be during the final exam period. That's just the easiest way to do it. So that is Monday. I didn't write this down. I should have. I can add it. Monday, May 11th at 8. Ours is our very first exam time. So this is posted on Moodle. You can go ahead and find it, but here's the tentative course schedule for the rest of the semester. Anybody, any questions on that at this point? No, good. Lauren, yep.
Are you still planning on sending like a more specific proof
rubric? Yep, so that was my next thing to talk about. So I started it this weekend. It is close to done. I want to proofread it one more time, and I need to figure out, so right now it's like, it has a bunch of categories and it's on a rubric and it has a 4-point scale. So like 4 points for this, 3 points for this, 2 points for this, etc. What I need to figure out is how to convert that to a grade. I can show you if you want to see it. I need to proofread it, but I'm pretty happy with where it is. So I can show you the basics of it, and then at least you've got something. My goal is to send it out to you today or tomorrow at the latest. But let me show you proof rubric notebook. I don't know how well you're going to be able to see this. But so here's what we've got. So proof correctness, proof completeness and citations. This one is just basically you have all the proofs that you're supposed to have. They're from the right category and they're all cited. Basically, that's this one. We've got mathematical symbols, correctness and conciseness. So remember, in the proof notebook, there's supposed to be a list of all the mathematical symbols that we've used and an explanation of them. You're also supposed to give me descriptions of each of the types of proofs and when you're supposed to use them, what the process is. So that one's in here. We've got mathematical correctness. So basically your proofs are right, is what I'm saying. Organization. So the last two are kind of the more nebulous categories, organization and then neatness and page layout. And I didn't get specifically into what organization and neatness and page layout looks like, because once again, I don't want to squash your creativity. So two people could have two completely different proof notebooks organized in different ways, and they could both earn a 4. That's totally possible. So these are broader categories, but these are the categories that I am looking at. And then again, my grading scale is not finished. So I need to figure out how to convert anywhere between 1 and 24 or 4 and 24 points into a letter grade, a percentage. So that's the part that I need to still work on this afternoon. But here's your basic categories that I'm going to be grading the proof notebook on. So don't like take a screenshot of this or anything and say this is good to go, but these are the basic ideas. Grace, question?
Yeah.
Yes.
The only thing I have a question on is which proofs do we put in this notebook? Like, is there a list of which types?
So if I pop up, let me pop up that one too. The directions for the proof notebook, the requirements. So we've got the different types of proof down here. All right, so logical equivalent, direct proof, proof by cases, proof by contrapositive, proof by contradiction, by conditionals. Those are the ones that we've done so far up to this point. Today, we are gonna start proofs of set theoretical properties. That's today. And then remember, chapter 10 is the proof by induction. So the last two categories we haven't done yet. And then also remember that you need 3 different proofs of each type. 2 of them can be from homework or a test. Should be from homework or a test. And part of the reason for that is I want you to go back and potentially, if you need to revise your homework or test proof, that's why I want you to pull these. And then the other one can be whatever you want. So present it in class from the book, but that wasn't assigned for homework, or something that you find somewhere else. Remember that you need to categorize these also. So like homework, test, etc. And if you do as homework, it should be from this section, from this page. If it's a test, it should be from test number 1 or test number 2, whatever it is. So that goes with each of those. Does that answer your question, Grace? Is that what you're looking for? Good. Okay, Lauren, yes.
So like when you're talking about like from what section or like page or whatever, is that like the citation part?
Yes, that is what I want for the citation. So I want a proof notebook with 24 proofs, and I should be able to instantly look and say, oh, okay, this is homework problem number 4 on page 18. I shouldn't have to go digging for where you found your proofs from. Or this is problem number 2 from test number 3, which doesn't work because you won't have test number 3 before you turn in your proof notebook, but you get the basic idea. That's what I'm looking for citations. If there's one that you find online, that is totally fine as well. If you want to go looking there, then you just need to give me the URL.
Okay. And then when was this due? Is it the day of the final exam or
what did I say in here? Hand it in the last week of class. So I'll leave it up to you guys. You can tell me what you think. Do you want it due at the final exam, or do you want it due that last Friday of class? Any preference on this? And you don't have to tell me right now. We can come back to this on Wednesday and decide. Maybe let's come back to this on Wednesday, thinking about whether you have a preference for the last day of the semester. That would be that Friday. And I would set a due time of noon, again, like we've done for our homeworks. So either the last day of the semester, that would be Friday, May 8th, or at the final exam, Monday, May 11th. So we'll come back, we'll revisit that on Wednesday. Help me remember to revisit that on Wednesday if I forget. Okay, can kind of think we'll do a majority roll. Any other questions about the proof notebook? This is a good opportunity to talk through some things with it. Other questions about the proof notebook? Going once, going twice. Okay, let's see. Questions about the revised schedule. Is this helpful? Hopefully, yes, a little bit. Okay, again, if things change, they change, and I'll let you know, but this is hopefully where we're at for the rest of the semester. Other questions on that or other procedural things before we jump into chapter 8? Anybody, anything? You good? Okay. Let me then close out my email so that I don't get emails during class. I left it open in case anyone had issues getting into Zoom. And let me share my whiteboard instead of my screen. And let me maximize my whiteboard. Okay, here we go. So, section 8.1. Proving that an element, so we'll call that little a, lives in a set, capital A. Section 8.1, proving that an element lives in a set. So we are moving into chapter 8, which is set theoretical proofs. That's the basic idea of chapter 8. It's called set theoretical proofs. That's the technical name for it, set theoretical proofs. And there are 3 types. So 3 types of set theoretical proofs, moving from easy-er to hard-er. And we're going to get each of those throughout the course of the chapter. So first of all is proving an element lives in a set. That's the first one. Proving that an element lives in a set. And this is what we're going to do today. This is section 8.1. Proving that an element lives in a set. Section 8.1. That's the first step. Second step is proving that one set is a subset of another set. That's the second thing we're going to do. Proving that one set is a subset of another set, and that's section 8.2. Okay, and then third is proving 2 sets are equal. And that is section 8.3. So proving that an element lives in a set, that's what we're going to do today, section 8.1. Proving that one set is a subset of another set, that's what we're going to do tomorrow, Wednesday, section 8.2. And then proving that 2 sets are equal, that is next Wednesday, section 8.3. The reason that they're organized in this way is because they build upon each other. So proving that one set is a subset of another set uses techniques that we're going to do today. And proving that 2 sets are equal uses subset technique proofs. So that's why we're organizing them in this way, because in order to do number 2, you need the techniques from number 1, and in order to do number 3, you need the techniques from number 2. That's why we're organizing them in this way. Okay, I need you to remember set builder notation. So recall set builder notation. Been a long time since we've done this. We haven't played with sets in a very long time. So remember, we use capital letters for sets. That's going to be A, capital A. And then usually we write this in one of 2 ways. We either say the set of all elements, that's the lowercase x, living in X such that P of X is true. Or sometimes we leave the domain off. We can just say that A is the set of all X such that P of X is true. So that's set builder notation. A, capital letters for sets, is the set of all X living in an S is some domain. So a lot of times it'll be the integers, but we could have rational numbers, or we could have real numbers, or we could have something else. The set of all X living in some domain, so that some statement is true. Or if the domain is clear and we say, oh, we're always going to be working with integers in this one, then we can leave the domain off. Okay, set builder notation for a couple of sets that we are very, very familiar with. So, for example, even integers. We know what even integers look like, right? So the set of even integers is, we'll call this capital A. This is the set of all X living in the integers, so that X looks like 2 times little a for some A living in the integers. We're really good at the definition of even numbers at this point in time. So the set of all even integers is the set of all x living in A, such that, you read the two dots as such that x equals 2a for some A living in Z. So to show that, I don't know, x is an even integer, we need to show that x looks like two, I'm going to change my letter to sailboat, two sailboat for some sailboat living in the integers. So this is to show that x is an even integer, or in other words, to show that x lives in my set A. You guys are really good at this. This is the reason that I'm starting with even integers, because I want to start with something that we're familiar with before we get to something that we're less familiar with. So to show that x is an even integer, what we need to do is look at the part after the colon. You pretend that this is your definition, and that gives you your need to show. All right, we could do odd integers as well. So if we go ahead and do odd integers, for example, odd integers, let's say that B is the set of all x living in the integers, such that to be an odd integer, we need x to be 2b plus 1 for some B living in the integers. So odd integers, again, we're good at this definition. Odd integers have to look like x equals 2b plus 1 for some B living in Z. So in other words, to show that x lives in B, what we need to do is need to show that x equals 2 sailboat plus 1 for some sailboat living in the integers, because that's what comes after the colon. So these are ones that we're familiar with already. We're familiar with these definitions of even and odd integers. I'm just putting them into set theory. We're going to get other sets where it's not a definition that we're familiar with, or maybe it's not a definition that we've seen before at all, but the process is exactly the same. You look for the equation after the equal sign, and that turns into your need to show equation. Okay, any questions before I clear this whiteboard and we do some examples? Anything? Okay, let's go ahead and run an example here. For example, all right, first up. So let's say, let capital A be this set. It's going to be the set of x living in the integers, such that x squared minus 1 is even. So A is going to be the set of x living in the integers such that x squared minus 1 is even. And what we want to do is prove, we're going to do this with a specific element here, that A equals 3 lives in A. So my set is capital A, x living in the integers such that x squared minus 1 is even. And I want to prove that A is equal to 3. That's the value I'm picking, lives in A. So my need to show is two things. Here's my proof. We need to show two things. First of all, that A lives in the integers, because that's the domain that I'm working with in this case. All right, so I need to show that A lives in the integers. My element has to live where it's supposed to. This is clear because obviously 3 is an integer. No problem. Easy. Usually the first part is pretty easy. No problem, A is an integer. The second thing I have to do is show that the part after the colon is true. So I also need to show that A squared minus 1 is even. This is a statement instead of an equation, but it's still the same basic idea. So I have to show, I'll stop drawing arrows after this proof, but I wanted to draw them for the first one. So I also have to show that A squared minus 1 is even. Make sense where that's coming from? That's the part after my colon, so I got to show that that part is true. All right, so to do that, we know that A squared minus 1 is equal to 3 squared minus 1 in this case, because that's A, right? So this equals 3 squared minus 1. I'm going to write out all the gory details of this, and then you don't have to in the future. So this is going to be 9 squared minus 1, which is 8, which is 2 times 4. I'm looking for this to be an even integer, and even integers look like 2 times something. So this is 2 times 4, which is even. Because 4 lives in the integers, right? This is 2 times something. Obviously, 8 is an even number. We know that, duh. But I'm trying to make it obvious in cases where you don't have quite as much of a duh moment. So this equals 2 times 4, which is even because 4 lives in the integers. All right, and therefore, we always want to finish our proofs with a therefore. Therefore, A equals 3, lives in the set capital A as desired. Yay. That's a set theoretical proof. That's your basic idea. So 2 things that you have to show, assuming that a domain is specified at the beginning before the colon. You got to show that your element lives where it's supposed to, and then you have to show that the statement after the colon is true for your element. Any questions on this one before we try another one? Anybody, anything? Okay. Let me stop sharing for just a sec so I can pause the recording.